We'll talk about this after. So what's a scale model?
Like something
It's kind of like a scale factor.
drawn smaller. or bigger.
Kind of, yeah. Okay, so basically it could be an object, or it could be a drawing. Right? With proportional lengths. To the original object or drawing. So, if you're thinking about a scale model, what's a great example of a scale model? A map is a really good one, right? And in the bottom corner, there would be a little scale, right? What else? Blueprint's a really good one, right? A model car, okay?
Oh, just anything.
Any kind of model, basically, right? But you would use a lot of this if you're gonna maybe think about architecture, thinking about your blueprints, absolutely, okay? So, obviously then, because we're talking about a scale model, we have a scale. So what's a scale? Down in, if you think about your map again, like Bradley said, what's the scale in the bottom corner tell you?
1 inch.
How many
100 miles.
inches? Basically the rate.
Perfect. So we want to say this is a ratio, so it's still a what? A fraction, okay? A ratio of, and then basically you can do however you want, but it's usually the length of the model over the original. Now, what's really special about a scale is that in a scale, you can have different labels. And this is really important for what we're going to do using a scale and then turning it into a scale factor. Okay? But different labels, everybody understand what I'm saying? They don't have to be the same on the top and the bottom. And that's what we would do. Somebody said, well, we would have like 1 inch is equivalent to 12 miles, for instance, right? And then we would just figure it out by either measuring it, so you're going to actually have to use a ruler, and that's where some people really run into problems, okay? Because apparently you don't know how to use a ruler a lot of the time. All right? So, yeah, trust me. You look at me like that, but it's a true statement. So the biggest thing that you have to make sure of is that you read your scale and you understand what your scale is in. Right? So are we doing it in centimeters or are we doing it in inches? And when you're doing it in inches, what are the little lines in between? 16ths, right? So you're going to have some kind of fraction if it's in between there. And it's always over a 16th. Okay, so you could turn it into a decimal, but just make sure that you, when you're measuring it, you go from the center of the circle or the dot to the center of the dot. And again, everybody says, oh, it's really easy, but trust me, I've done this a couple years and it's not that easy. Okay, so the other thing that has to occur when you set up this proportion, because then they're going to give you some kind of information. We're either going to measure this using our own ruler and then trying to figure out how many miles it is, or they're going to give you how many miles it is and then basically ask you to put it on the paper as inches. But what we're saying here is across from each other needs to be the same measure, right? So in this case right here, I'm always going to have inches over here and then I'm going to have miles here. So realistically, you could take this rate and flip it upside down if you wanted to, but then the other one's got to flip upside down. You don't want your labels to cancel out in this one, all right? That's really important. Okay, so we're just gonna set up a proportion. Once we have a proportion, we get what we want. So here's my question. The distance between Boston and Chicago on a map is 9 inches. If the scale is 1 inch to 95 miles, what's the actual distance between Boston and Chicago?
235 miles.
How much?
235 miles.
Because you did what?
I multiplied it. 9 times 95.
Okay, so we'd have 1 inch is to 95 miles. So we're going to leave that and say, now I've figured out that it was 9 inches. How many miles is it?
What did you say it was?
And I don't think Cam's right.
235?
Cam, 95 times 9?
5 times 9? It's 855.
Oh.
So we'd get 855. So again, we'll just multiply 95 times 9 and divide it by 1.
Oh, I did 1 time or 2 times 9 to get 18. I don't know where I did that.
I don't know either. Okay? So, it's pretty simple, but again, make sure that the hardest part of it is honestly this part right here. Okay? So, when you do this on the quiz and the test, you need to make sure that you're as close as you possibly can. And it's okay to have decimals, or it's okay to have a fraction as a part of your inches. So just because it's close to 2, you can't say, ah, heck, it's 2 inches. That's not how it works anymore. Okay? You gotta be as precise as you possibly can. Okay? Make sense? So, from here then, every single time that they talk about a scale again, make sure that you're, so we're still continuing in here. This was our example, but we're still talking about scales here. Make sure that you reduce to simplest form. How do you spell simplest?
I didn't mean that to be rude, but spell.
So what I'm getting at here is sometimes they'll give you a scale and you just have to look at, you don't necessarily need a 1 up here, you just need to take out as much as you possibly can from both numbers. Some number that's in both of them. You're basically looking for a common factor, okay? When you do this, again, then always try to do your the ratio of the model over the original too. When you start doing these in your problems, okay? And you'll understand this more when we get to the next part. From there, then we talk about moving from a scale, which the biggest thing with me with scales is that you can have different labels, to a scale factor. So we've talked about scale factors the whole time, right?
Yeah.
Or at least the last couple sections. And that scale factor is what shows how much that you're either going to blow it up or you're going to shrink it, right? So if we had Trevor's model car or whatever, how much is the real car to his model car? How many times did we blow that up, right? Not actually blow it up, but make it bigger, okay? So we're not blowing anything up, but so a scale factor is really telling you the number of times the actual is to the model. Okay? And what's important about a scale factor, you want to cancel all the labels. So you're going to have different labels, right? Like in this one over here, inches are to miles. You want to be able to cancel all those out. And so basically we would say, well, if we would have done this one, you would have changed your inches and canceled them out by doing conversions. So again, this right here, and this is where it gets a little complicated, even though it's a frame of mind, these are your conversion factors. Okay? When you do conversions, what's important? Well, you're still going to set up kind of a fraction times a fraction, right? But in this, if I have inches over miles, Then when I multiply the next one, I want my inches on the bottom, so when I go back and look at it, my labels all cancel each other out. So basically, you're gonna go through and you're gonna try to figure out how to cancel out all of your labels. And then, so you could have multiple fractions being multiplied together, and as long as you go back and you look at, in this case, all of your labels being canceled out, then whatever's left over, you multiply across the top, you multiply across the bottom. And then you'll end up with a number, and it'll show you how many times that your figure got blown up, okay? So a conversion's, in a sense, you're in a scale factor, your labels should always be the same, but we're essentially just gonna cancel all the labels out. So they're all talking about the same thing. And this is my scale factor then, okay? But again, if the model is smaller than the original, we would go back to what we talked about yesterday. K's gotta be between what? 0 and 1, right? And again, when we say that, then we're saying that it is a fraction. If K is greater than 1, then we would say that it's blowing up, or yeah, it's just bigger, right? It's bigger than 1. So it still could be a fraction, but we're gonna blow it up. And we'll show you an example of all this in just a little bit.
So the conversions, if you did like inches to miles, but you didn't know like how many inches, you go inches to feet and feet to yards.
Absolutely, yep. You go inches to feet and feet to then miles, or some kind of conversion, and you might have to do multiple ones. And a lot of the major ones are in the back of your book.
Oh, okay.
The back cover,
On huge.
okay?
So
The actual back cover.
It's all the way back. I got from
You put feet on top of inches.
Yeah, so I would say, I'm gonna go, there is 12 inches in 1 foot, okay? But now I have feet here, so I know that there's 5,280 feet in 1 mile. And now if I look at this, my inches cancel out, my feet cancel out, and my miles cancel out, and I'm ready to go. Okay? So in this one, if we would come back here, we would have 1 here and 95 here, and then we're just gonna multiply straight across. So there's no numbers on the top besides 1, so we know that it's 1 over, but if I take all of this, that's how much it would blow up.
Multiply across, or multiply diagonal. That's cross multiply.
Right.
That's just two.
If I'm thinking about diagonal, I'm thinking about reducing when I'm multiplying. It's different than a proportion, because a proportion, they're equal to each other. This is an actual multiplication
Why'd
problem.
you put inches across from inches?
Because when I'm switching it to a scale factor, I want to cancel out my labels. Okay? So, did anybody punch that into your calculator? We don't want Cam to do it because
Hey, I'm
you get
dyslexic.
237.
I'm just, wow.
So this one's going to be quite a bit bigger, right?
6, oh, that's a lot.
No, it's way more than that.
6 million, I think. You failed. 6019200.
What is this now?
16 million.
Oh, you get 16.
Hey,
What? Oh, 6,019,200.
Okay, so our map compared to the real life is, they're saying that you would have to blow up the map 6 million times to get the actual distance. That's what that's saying. Or you would shrink it 1 over 6 million times to get it down to the map figure. Okay? So, here's my problem. A miniature replica of a fighter jet is 4 inches long. Okay? The actual length of the jet is 12.8 yards. So, the first part says, what is the scale? Alright? So, it says that we have 4 inches, and on the bottom we have 12.8 yards. Alright? So, this is a scale, right? Because they have different labels. But if you looked at those two numbers, is there something that jumps out to you that you can take out of both? Yeah, so I'm going to take out a 4 from both. So I end up with 1 inch is to what?
3.2.
3.2 yards. Okay? So that would be my scale. And then if it says in the next part, how many times as long is the model as the actual jet, then we would do the scale factor part that we did over here. So let's convert this into canceling out all of our labels. So what?
1 yard into 36 inches.
1 yard equals 36 inches. Do I have to do anything else?
No.
If you jump right to that one, then you don't have to do anything else because my inches cancel out, my yards cancel out. So on the top, I get 1 over, what's 36 times 3.2?
115.2.
115.2?
Yeah, is that what you got? Not quite.
Yes,
Alright.
Should be this way.
I did.
Is that a 7 or is that a. What is that?
This right here is a 0.
Oh, that's a 0.
It looks like a Rulin's 9. you know.
Hey.
Yeah.
So, what does this mean? What does this mean?
Oh, that means it's there's.
Blown up
Oh,
150.2 times.
So if we were actually looking at our 2 jets, we put the little jet and set it right next to the big jet on the, what? Runway, thanks, I couldn't think of that word. That means that we would have had blown up or shrunk the actual jet 115 times. Or we would have taken that little jet and blown it up 115 times to get to the actual. Pretty cool, right? Okay. Questions there? So again, if they ask you for the scale, you take the 2 numbers, put them over each other, and reduce. If they ask you for the how many times or the scale factor, you eliminate the labels. Okay? Questions here? The next part to me, for whatever reason, even though it's a, what'd you say? Mindset, is that for whatever reason this is hard for people to do. So I think it's probably the easiest.
What we forget.
No, let's just go this way. So does anybody need more examples of the first few? Anything with that? So again, if we already did the Boston one, does anybody need another one like that? So again, there's my scale on my map. So this one was 1 to 90, and then we would just make sure that my inches are in the same spot. Everybody good with that kind? Okay? So then, does anybody need to do another one of these kind with the replicas?
No.
There's another one of those if you want to do a replica one.
Wait, why'd you. On that one up there, why'd you put 3.2? Because it's 12.8 divided by 4?
Yes, I'm reducing both of those numbers by the same number.
What if you could do that?
Then you would just leave it.
Then it just be 4 and 12.
So if this was 5, good one. Then we would have 5 inches over 12.8 yards.
And we just go. And that's just.
And that's my scale. Yes.
How do you know when to do a scale factor or when to just do a scale?
When they ask you to, they'll ask you to make the scale, and then if they say how many times, that's when you turn it into the scale factor. How many times did actual get to the replica or whatever?
But,
Or ask you to find the scale factor. That's the same thing.
and if it was 5 over 12.8, you still go through all what we just did.
Yes, but this would be one answer and it would stay as that weird fraction kind of. And then the other one would be that. Yes.
Oh, okay, that'd be your scale factor, then your scale would be.
Right. Right. Okay? Everybody good with that? Now we're doing action photos.
No, because the
All
camera.
right, the last one's a little weird, like I said. So, here's the problem. Read this problem. Gerard is making a scale model of his classroom on an 11 by 17 inch sheet of paper. If the classroom is 20 feet by 32 feet, choose an appropriate scale for the drawing and then determine the drawing's dimensions. So do you understand what we're saying? We're basically trying to become amateur architects, right? If we look at this room right here, we're trying to put this on a piece of paper for everybody to see. And instead of doing that, you know, just one room to one room, we would try to do the whole school on a thing. So, how do you go about this? Well, see this right here when they tell you what the dimensions of your paper are compared to what the dimensions of the actual building are, or the room is? You're going to take those numbers and you're going to take the actual building, which is 20 feet here, and I'm going to divide it by what we want our paper to be. Okay, so 20 feet over 11 inches, this would be the what? We would basically say this is the width. And maybe it's the length, but it doesn't really matter.
You can choose
Okay.
one of those.
And then the other one, I'm going to say we would have 32 over 17. Okay? Everybody okay with that? All I did was make them into fractions. But I have to make sure that I'm looking at the same things, meaning the lengths and the widths. Okay? Now, if you punch this into your calculator, Gabriel, 20 divided by 11, somebody else do 32 divided by 17 in your calculator.
1.88.
Which one do you do?
The second
How much you get?
one. 1.88.
1.88.
The first
Gabriel?
one is 1.82.
1.82. Okay, everybody see what we're doing there? Now, obviously, how many people like to work with decimals? Put your hand
I
down.
do, actually.
Okay, so instead of trying to make these two numbers, which aren't the exact same anyway, I'm going to round where I can fit both of these numbers into the next whole number. So if I can round these, basically both of these I can turn into what? 2, right? And so basically we're saying that for every, now, if I came back here, I have 11 inches for my paper to the 20 feet for the width. I'm going to say that for every 2 inches, so basically we're coming back to the scale at the beginning when we did it on the map. But now we're just doing it on a piece of paper. So now we're going to compare that to every 2 inches was how many feet in my picture or my room. Okay? So if I do the math, we get what? What's 20 times 2 divided by 11?
40 divided by 11 is
3 point something.
3.67.
3.67. And we would have that in feet, right? So every 3.67 feet would equal 2 inches on our scale. Okay? And then if we would go about the other way, you could figure out the other factors of it too.
How'd you get 367?
3.67.
What's
It's
the
3.64 actually.
20 times 2, yeah, it's 3.64.
Did you mess up on my
I
thing
didn't
again?
see the 3 between the 6 and the 6.
So what is it now?
3.64.
So,
Yeah.
how'd you-
alright, so if we came back here, we're gonna say, sorry, our factor was 2, right? So for every 2 inches, we would have, and so what they come up with then is every 1 inch is equal to 2 feet. So if I came back here and said, how many times could I put 11 inches into 20 feet? That would be my 2. How many times could I do 17? 17 times 2 would get me to 34, but we're just rounding it down to a little bit.
Oh, so that's how many times I should. Oh.
Yeah, so we're just making our adjustment and trying to figure out by using the 2. My proportion here didn't really
So
do us justice.
take the bottom label
I'm confused.
for like 2 inches. You took 2 inches. You always take the bottom like long.
People have inches.
Say it one more
It's
time.
20 feet over 11 inches, and you made it into 2
Oh, yeah.
inches. So do you always take the bottom and middle?
Right,
Okay.
right.
And so that's your answer, two's your answer.
So basically I'm saying that if I went back to this and I took 20 divided by 2, I would say how many inches do I have? 10, right? So I'm going to then take this, what I figure out, I'm going to take this back to my real world picture, and I'm going to take each one of them and divide by that. So this would be my width, and this would be my length. So 20 divided by 2 gets me 10 inches. 32 divided by 2 gets me 16 inches. And on my piece of paper, I would draw it as 10 inches wide and 16 inches long. And it would duplicate my actual room
So you
size.
it's like 11 inches and 20 feet don't matter. What you tried to do earlier.
Right, sorry. This part, that led us astray. We just want to figure out what the closest number is, and then divide it back from each of those
So we do
original
five
numbers.
Why can't you do 11 and 17?
Because that is what my paper is. I just have to know that this right here is gonna fit on my paper of
Also,
11 by
that's like the
17.
dimensions of the.
Yeah, yeah, okay. So let's look at another one of these, because like I said, they do get a little interesting. Don't look at it, Gabriel. Alright, so Elena is an architect making a scale model of a house in a 15 by 26 inch display. If the house is 84 feet by 144 feet, what would be the dimensions of the model using a scale of 1 inch is to 6 feet? So basically they did it for you, they figured it out. But if you wanted to go through this process, you could just figure it out by doing what? If I take 84 divided by 15, what do you get?
5.6.
5.6, and if you did 144 divided by 26, what do you get?
5.53.
5.5. So between those two numbers, again, I don't want to use decimals, so they rounded it up to 1 inch is equal to 6 feet.
So then you work.
So then I'm going to take this, and if I look at this, if I take 84 divided by 6, what do I get? 14. And if I take 144 divided by 6, I get 24. So 14 inches by 24 would fit on my piece of paper or canvas or whatever they're talking about, my display case.
Why do you only use 144?
What do you mean, why did I only use that? I took 144 divided by my 6, because that was the actual dimensions of it, of the actual room
So
that we're talking
what was
about.
the point of finding 5.5?
Well, that's how they came up with this.
6, they
So
were
you came up with that 6.
They pushed it to 6 because the 5.5 would fit inside of that 6.
Okay,
So we didn't want to use a decimal like this, so we upped it up to 2.
so then you just
In this one, we had 5.6 and 5.5, so we upped it to 6, and we made 1 inch is to 6 feet. Over here, we would have said 2 inches was equal to whatever. Remember?
So then, based off of those fractions that we needed to find the scale or whatever, they plug that 6 back into the numerator of those fractions.
Essentially,
To
yes.
find dimensions.
And then they divided the real world by what we came up with in our scale.
But you always use the bigger number of the scale?
Well, just because they're both feet, I'm going to divide them
Okay, so.
5 feet.
Inches.
I'm turning them into inches by doing the math.
Yeah.
I'm really doing a proportion, but essentially it's 1, so I'm just doing 84 divided by 6.
But you're always doing that big, you're always doing that number that has the same label as the.
Yes, yes.
I'm assuming it doesn't matter if you're 24 times 14. It's interchangeable.
Well, no, you should go by what they did. So basically, they're saying this is the width and this is the length, I would assume. That's why they did it that way. If you turned it around, then you would have just had to say, see how they said 15 by 26 here? That's why they did it that way, instead of saying 26 by 15. So it's 15 this way and 26 this way, I would guess. Okay? So these problems right here, they get a little confusing, but basically they're just saying, how can you take the real world thing and fit it on a piece of paper by making some kind of a scale factor or a scale, and then you're turning it into. You don't need a scale factor for those ones, sorry. You're just doing your scale. Yeah. The biggest thing is if you can measure your little distances on a map and set up your own proportion. That's going to be the biggest thing for the quiz and the test. This is the last section. So tomorrow there will be a quiz.
What is not a test?
Quiz.
Test is Tuesday.
Most likely.